This example has three parts to it. The first part says to us, find the Cartesian equation of the path of an object whose position is given by, and we're told the unit vector r equals 3 cos t in the I direction plus 2 sine t in the j direction, and of course time is greater or equal to 0. So we look to see what the I component is. The I component tells us x is equal to 3 cos t. So I've written down x equals 3 cos t. I can get the cos t by itself by dividing by 3. So I get x divided by 3 is equal to cos t. I'm not going to try and get t by itself by taking the inverse cosine of both sides. The reason why will become apparent shortly. Now we're going to get the y part of this equation. We can see from the equation y is equal to 2 sine t, which is what I've written down. Dividing both sides by 2, I get y divided by 2 equals sine t. So what I have there is x over 3 equals cos t, y over 2 equals sine t. I'm not going to take inverse sine or inverse cosine of either sides of the equation. It would give me something which would be very difficult to work from. What I am going to do though is recognize the relationship for the circular function identity cos squared t plus sine squared t equals 1. So squaring cos squared t, I get x over 3 squared equals cos squared t, and squaring y over 2, so I get y over t squared equals sine squared t. So I've now substituted x over 3 all squared plus y over 2 all squared to replace the cos squared t plus sine squared t. This has eliminated the t and only left me with x and y. So squaring those out, I get x squared on 9 plus y squared on 4 equals 1. I am now asked to sketch it. Now, this object is following an elliptical path. That is the equation of ellipse. So the equation of the ellipse, I can see the bottom line underneath the x squared is 9. So square root of 9 is 3. So it's going to have x-intercepts at plus 3, minus 3. I can see the y squared part is over 4. Square root of 4 is 2. So it's going to have y-intercepts at plus 2 and minus 2. What I haven't considered here is where the particle actually starts. I'm not asked for that in the question, but it is worth looking at. When t is equal to 0, I have x is equal to 3 cos t. So 3 cosine of 0. The cosine of 0 is 1. 3 times 1 is 3. Y is equal to 2 sine t. So I'd have 2 sine 0. Sine of 0 is 0. 2 times 0 is 0. So this particle is starting at the point 3, 0. I'm actually going to mark that in on the graph so you can see. The last part of the question says, state the period of the motion of the particle. So if you have a look in front of the t for both the I and j components, you'll see there is a 1, we know the formula for period is 2 pi on n. N in this case is 1. 2 pi on 1 is 2 pi.